Good afternoon, and thank you for joining today's webinar from Spec Innovations, LML to SysML and back. My name is Elizabeth Steiner. I'm the Director of Marketing and Communications here at Spec Innovations, and I will be your moderator today. First, let's go over some quick housekeeping. During the presentation, feel free to send us questions, and we will get them answered in the question and answer part of the webinar. You can also interact with us on LinkedIn through the Innoslate user group or through Twitter using the handle @Innoslate. The webinar is being recorded and we will make it available to you after the live presentation, so be sure to keep an eye out for it in your inbox. Now I would like to introduce you to our presenter, Dr. Steve Dam. He'll be sharing with you his knowledge in SysML and LML and how Innoslate can use them together. Dr. Dam is the president and founder of Spec Innovations, as well as one of our DODAF training instructors. He has been involved with research, experiments, operations analysis, software development, systems engineering, and training for more than 40 years. Dr. Dam is an active member of the LML Steering Committee. He has also received an Expert Systems Engineering Professional certification from INCOSE. Currently, he is applying systems engineering techniques to various DoD, DOE, and commercial projects. Feel free to send Dr. Dam any questions through the LinkedIn user group or send him an email after the webinar. And now I will hand over the controls to Dr. Dam and we will get started.
Thanks, Elizabeth. Appreciate the intro. So today we're going to talk about LML and SysML, and we're going to assume that at least some of the people in the audience don't know what LML is, and maybe not even what SysML is, so that's okay. We'll get into each of the basics of those first and talk a little bit about the benefits of each, and then get into a demonstration showing you an implementation of where we've been able to create the SysML diagrams from the LML Ontology and go back and forth. And then we'll have plenty of time for questions and answers. So without further ado, let's go on. So it's a common practice for systems engineers to use a wide range of modeling languages, tools, and techniques on large systems projects. That's from the SysML specification itself, which is kind of interesting because, of course, the whole idea is what you really want is a common language as much as possible to help facilitate the communications. And so let's get into the basics of LML so you can think about, see, one of the things that we realized was one of the problems in this area today. So the goals for Lifecycle Modeling Language was, first of all, making sure it was easy to understand. Wanted to be able to reach as many audiences as possible with it, so it'd be common words that people are used to using, common English words, I should say, and also to be easy to extend, recognizing that you don't want to have too much there because you want people to have specific ability to extend it for specific domains and specific needs. So you wanted to be flexible. So really, we look at this as kind of the 80% solution in terms of your language capturing. Also, of course, to support both the functional and object-oriented approaches within the same design, software programmers over the years have realized that both the object-oriented approach and the functional approach have pluses and minuses. And so, in fact, many of the languages today are hybrid languages that people use. And another thing, we want to make sure the language can be understood by the system stakeholders, not just the systems engineers. Systems engineers are supposed to be facilitators of communication between the stakeholders and the detailed developers. So you want to be able to speak, user speak, whether it be a mission analyst or talking to a senior manager in a corporation, but also be able to talk to the IT people and talk to the electrical engineers, the mechanical engineers who are working on a project. So having that ability to facilitate between all those is very important. Another thing we recognize is systems engineers support systems from the cradle to the grave, the full life cycle. And so you're not just talking about the design portion or the detailed design of, say, software. That communications can happen between the systems engineer and the software engineers. But after all, that has to then also be working with the test evaluation people, and of course the people in operations and support as well. So, and of course the idea is to deal with both evolutionary and revolutionary changes to the system plans and designs over the lifetime of the system, recognizing that many of our systems last for decades, and we want it that way. And so you want to have the ability to make sure that this can support that, because over time the technologies change, things change in ways that are difficult if you don't have a language that's flexible enough to deal with that. So that's basically the entity relationship attribute, which is considered the meta model. That's a little bit of a fancy name for it, but basically the underlying structure for the language elements. And I'll make it clear why that's obvious here in a minute, so you can relate it to English language. So an entity is something that can exist by itself and is uniquely identifiable. LML has defined 12 parent entities. There's the list. As you can see, there are technical and programmatic kinds of pieces of information in here. It's not just a technical problem. And also we've identified several subclasses of these that would give us more specifics. For example, statement. Statement's the general piece of information that you want to capture, maybe as part of a requirements diagram. It gives you requirements document. It gives you the context for the requirements document. But then the specific requirement has other attributes that are very important that you want to make sure that you can identify that. So there's a subclass of statement we recommend called requirement. And of course, all these different entities need to be able to be related to one another in a consistent way. One of the things that makes that hard sometimes is people don't realize that you want to use the same verb whether you're going to or from something. So between the two, you know where you're going. Also, you want to have consistency in like hierarchical names. So we use the term decomposed by and decomposes for all the hierarchy. So again, once you get into kind of using those kinds of terms, it makes it easier to understand and easier to follow. It's not confusing. Well, if the entity is our noun, that means the relationship's sort of the verb. And so you think about those two things. Well, okay, that's just some basic elements of language I need in any language. So a noun and a verb. And then if I have the third is attribute, right? So attribute gives us the characteristic or quality of the entity or relationship. So in other words, the attribute can be on the entity, and it's like an adjective, and it can be an attribute on the relationship. It'd be like an adverb. So again, that gives you that strength of the language. If we implement it when we implement it this way, it makes it flexible. It makes it less complex looking, yet it can contain the entire complexity of the language that you need. Here's an example of the attribute on the entity. I'm sorry, on the relationship. And so you can see we have two entities, an input, output, and action, and they have a relationship called receives and received by. So in each way, depending on which way you're looking at it. And then we put an attribute on it called trigger. And the reason we have that is it allows us to determine if the input-output triggers the action. In other words, the action has to wait for that piece of information to execute, or can it just run without it? And so that's an important factor when you start getting into the actual modeling you do, the functional modeling, particularly with action diagrams or activity diagrams in SysML. So here's a little more detail about each one of them, and you can see that the different aspects of it. So going through them a little more closely, you can see action. And action, you can see the examples we have of that: activity, a function, a capability, a task, process, event. So you can see you could use all these things could be types of an action. So one of the attributes we recommend in the language or specify in the language is that a type attribute. So this would allow you to separate things. If you want to separate activities from tasks for some reason, which is perfectly fine, then you ought to have a ability to do that. This does let you do those kinds of things. But they are really fundamentally the same kind of thing. So we don't want to have a whole other bin for it, which gets very confusing to people, particularly when you're starting to do database structures. Some of the others, artifact. So this is the ability to capture artifacts. An artifact can be a document, emails, procedures, specifications, anything that you want to capture and understand and maybe reuse and create a knowledge base with. I won't go through all of them, but you can see some of the physical world is starting with the asset. Characteristic is an attribute, kind of like an attribute, but it's really another class. It gives you the ability to characterize assets or even actions and other things here. And you go on to conduit, gives you your physical connection. There's a connection higher class. So you notice that this is a parent-child. So you can see the parent-child relationships in the in the second column. You'll see where there's a parent. That means that the entity name is an actual child. So there's different kinds of connections. There's a conduit and a logical. And so these are ways to, again, relate them to each other and work through it. So again, what makes it a child means that it has to have some kind of unique attributes and or relationships. A good example is measure versus characteristic. Characteristic will has a value in it. Measure gets into threshold values, objective values, direction of goodness, which is direction of improvement. So a lot of other attributes are shown up with a measure. This is where you would capture your detailed metrics of a system. Notice that the child, of course, relationships inherit attributes and relationships from the parent. So we are doing object-oriented kinds of thought in how this was developed as a set of classes that could be used and reused throughout your work. Here's some more, and one of the ones we've gotten into many discussions about, and I know some people say, oh, well, I don't believe this language because it's got orbital in it. Well, orbital has some very unique attributes, and the way you specify an orbital location is difficult, and different relationships. If you think about orbited by, orbits, you know, that's really a different kind of relationship than an actual physical connection between the two. There's a gravitational connection between them, yes. I guess you could model it that way, but most people don't think of it that way very easily. So this is a way to capture that. And since systems engineering community, a major part of it is the space community, both commercially and in defense, we thought that was a valid thing to include. But that is one of the, I know that's one of the controversial things about the language I keep hearing from people. Let's see if there's any other major ones in here. You can see, again, requirement and statement I mentioned earlier. We also have virtual locations, so the ability to identify where your virtual things are. So that's your URLs that you can find things very quickly between on the net. So, and again, also another one is risk. So risk was a key element that we want to do, because if you think about risk is a technical problem. It's not just a managerial problem. Most of the time I find that people will ignore risk to their own detriment. And so the technical people have to be engaged in that as well as the management people. So this is one of those that's kind of both worlds. So that's a very quick snapshot. The specification is on lifecyclemodeling.org, and so it's easy to get the whole specification downloaded. It is an open standard. It's meant to be used by anybody, anywhere. Here's a little bit more about the relationships, and this is the traceability relationships, particularly. And again, you see I hope you can understand that when you see the circular, it's showing that's a hierarchical relationship. So all the hierarchical relationships are decomposed by and decomposes, as I mentioned earlier. And some of the other traces, sources by, traced from, performed by, specified by, again, gives you that vertical traceability set between the different things. This is a common way to look at it, where you start with an artifact, maybe you start with a requirements document that you inherited, and then you're going to decompose it into statements and requirements, and then you're going to then take that, make the sources of those, and then you're going to then use those to trace to actions and or assets. Actually, you find you do trace to more than one type usually, but the idea is to go through the functional analysis to understand, and then of course the physical part, how do I instantiate it, and capture the metrics and characteristics of the asset itself. And of course they have to be connected to each other, as I mentioned earlier, and that input-output then is transferred down the conduit to help you see that. So again, you start doing your communications modeling in more detail with this language. It gives you all that breadth and depth that you need to do a fairly complete job in systems engineering. Here's a mapping of the ontology to the different domains, and those who are not used to the ontology word, it simply means the set of classes that we came up with, which is called a taxonomy, and then that whole list, then how they're related to one another. That's basically an ontology. So, so we have systems engineering, architecture, program management, and of course then shows you the different parts of the lifecycle modeling language. So as you notice that some of the languages, some of the other domains don't use all of them, all the LML words, but the reality of it is you probably are doing a spectrum of these activities all the time. So it's actually very useful to have them all together in one place. And of course, nothing prevents you from adding extensions to this if you have other domains you need specific things. Let's say I'm using it for electrical engineering. Well, obviously, electrical engineering has its own language. You'd want to then maybe map some language elements to tie that language to this language. And so that would be a natural extension. One of the things that we also came up with was 3 diagrams that were basic, that were mandatory. And these aren't unique. I mean, you will find these kinds of diagrams in other languages, in other sets, and that's okay. But the one that's a little different, particularly, is the action diagram, which shows up in the upper left. That actually has no constructs in it, which means that now everything's a special case of the action. So you can see the loop down there at S111, target destroy. That's a loop. That has the entrance criteria and exit criteria for the loop. Well, that's nice, because actually that's an important piece of information that's probably part of your command and control structure. And so that's a function in command and control that you can then allocate directly to command and control. That way your process model can embed the command and control or information assurance or other decision points all through your logic of your process, simplifying it, making it clear who does, and then you also then see who does what functions very quickly. The physical diagram below it is called the asset diagram, and that's used for physical modeling. It shows the different assets and the conduits between them. And then there's nothing wrong with it substituting boxes and lines for pretty pictures and lightning bolts and things like that to help it communicate better. So that's what we recommend for that kind of visualization. And then the third one is the spider on the right of the diagram, right in the middle of the picture here. You see that gives us our traceability. It shows how we can trace between the different entities that are in the database with each other. And these lines are relationship lines from the ontology. So that's how you see that. Of course, 3 diagrams is not enough. You want to be able to visualize all the information. So it's highly recommended, and numbers other suggested diagrams were made for each of the classes in the specification. For example, the risk matrix for risk is an obvious one. The Department of Defense particularly likes to use this 5x5 risk matrix. Well, sure, why not? You should be able to characterize your risks that way and be able to put them into different boxes that make up the matrix. So again, common visualizations is the emphasis, because what you don't want is to reinvent that wheel. If people understand things in a certain way, it's best to portray them in that way. Maybe people are always used to seeing budget numbers, for example, in a pie chart. Great, that's the way to do it. But there's no reason to specify a pie chart as the only way to do it. I can use line charts, I can use bar charts, I can use all kinds of other graphical presentations. So extensions, formal extensions can be submitted to the steering committee, the LML steering committee, which I'm the secretary of, and Dr. Warren Vanneman from Naval Postgraduate School and Virginia Tech is the chairman of that committee. And so that group would then review any official extensions and then go ahead and publish them as quickly as possible. Just recently, we added the version 1.1, which added the entities, attributes, and relationships for SysML support. So what we recognized when we looked at it was there are a few little things that this didn't do for SysML, that SysML has specific things. And we probably didn't even capture all of it, but we think we captured the essence of SysML by doing this. So you can see those specific extensions that are highlighted in an appendix in the specification. So instantiation. So one of the things you have to do is be able to put this into a usable tool, or it's just a language that's hanging out there that nobody uses. It's just like I can write the greatest software development language like Java, but if I didn't create Java compilers, who'd care? So we did go ahead and make an instantiation of that in a tool called Innoslate, which our company does provide. And in fact, there are free versions on the cloud to look at and work with and test for your use, and even use if you're comfortable with using the cloud and the cloud security, which a lot of people are these days. But any other instantiation is certainly up to any other tool vendor, how they want to use it and how they want to implement it. I can think of several tools off the top of my head who can pick this up very quickly and use it very easily. Now, the one thing that we did when we instantiated LML for Innoslate was we realized that labels are a great way to sort things, and the type attribute was really a way of sorting and filtering information. And so that's how we implemented that there. And of course, we also did include specific diagrams for every class. We constantly get suggestions for additional diagrams, which we're always happy to add, because we think you ought to be able to visualize things any way you want to visualize the information. So fairly easy to use by any tools that already have schema extensions. In fact, I actually prototyped this in another tool first, the language, to see make sure it would work in other tools. But of course, it couldn't do things like the action diagram, or it may not have a spider diagram. I don't think it had a spider diagram at the time to be able to use it for that purpose. So again, it's something that the vendors themselves might want to have to add. But if you're happy enough with the SysML activity diagram, again, that might be, you might think that's a functional equivalent and be comfortable. If the other tool has it, that would be fine. So that was a very quick summary. I know it still took 20 minutes, but that's a very quick summary of the language itself. I've done actual full-day seminars on this, so that's why that's probably sounded like you were drinking water from a fire hydrant. So let's talk about the basics of SysML, and I'm going to assume that most of the people in the audience are more familiar with SysML anyway than they are with LML, so I'll do that a little faster for you. So for those who don't know, that SysML is a profile, or again, I don't know why they use the term profile. I'd rather use the word extension. Everybody understands that profile is actually confusing language to me, but that's fine. That's what they chose. And so it's really an extension of it. It added some different diagrams to the set of UML and reused a number of UML diagrams within the set. There's no ontology explicitly at this time. I understand that one is in the works. They are working on one, but I'm not sure where that sits. And then, of course, compliance with SysML requires a subset of UML is required for SysML is implemented, and that the SysML extensions to this subset have been implemented as well. So obviously, to be compliant, you have to actually do all the things that they ask to do, which makes sense. So you take a look at the diagrams themselves. You can see the different diagram sets. So the set of diagrams starts up here at the top. It's just the hierarchy. So you have different types of behavior diagrams. So the specific instances of behavior diagrams are activity, sequence, state machine, and use case. And you can see which ones were inherited from UML. The sequence and state machine were clearly already in UML. Activity, they had kind of an activity diagram, but it was modified from the UML. So there are only a couple of new diagrams. The requirements diagram and the parametric diagram are the two completely new ones, as you can see on the chart. So again, this is used. SysML is in heavy use out there now, at least in the system engineering community. It definitely requires, specifies that combination of techniques to give you a precise language, to give you some balance, some rigor, and understandability with it. So you're always looking for that in systems engineering. We're trying to put just enough rigor so there are constraints on things, but not overly constraining it. So there's always a balancing point with any language or something like this. And of course, you might apply, and this is there says that they may apply more formal constraints in semantics in the future, which of course means an ontology as well, potentially out of that. So one of the things, one of the nice presentations I saw fairly recently was this idea of the different 4 pillars of SysML, which is the structure on the top left here, the behavior on the top right, and then the requirements on the bottom left, and the parametrics on the bottom right. So remember that the requirements diagram and the parametric diagram are the 2 new diagrams that are there, and there are different types of behavior diagrams and different types of structure diagrams. So I think that's a good way to look at the whole mechanism of SysML. Okay, so that was a very, very quick look at SysML. So I apologize if for anybody who doesn't know it in more detail. There are books on the subject, so you can find out a lot more information from them. Okay, so let's talk a little bit about what's the benefits of a SysML. Well, if you're doing a software-centric system and you're talking almost always to software engineers, and they're using UML, and by the way, that's a big if, because I've run into a lot of software developers who don't even know what we're talking about when we talk about UML, except the class diagram. So that's a kind of interesting situation. And so there's that linkage between those that give you some value particularly. And that was a lot of the focus. I mean, if you know what the history of the object management group and the consortium that put this together, they were very focused on software and software systems engineering. Again, the specific diagrams across a number of systems engineering. I will say the requirements diagram and the parametrics diagram, I think, have quite a bit of utility, and adding them new was quite good. But they're a little more complex, I think, than they necessarily need to be. So it's one of those things, it's a double-edged sword a little bit. But I will say one of the things I really like about SysML is it's been encouraging model-based systems engineering. I've been doing model-based systems engineering for at least 25 years, long before SysML came around, and thought that was really the only way to do it, frankly. But turned out that a lot of people thought just playing with documents was enough, and they thought they could manage the documents well enough that that's all needed. I had taken a model-based approach where you have a database to capture the information in a strong schema/ontology that now you have the ability to reuse that data and work with that information in a nice coherent set, and then not duplicate information in a lot of different places, which happens with documents very easily. And when they duplicate the information, they almost always change it and then make them in conflict with each other. So invariably, if you're doing a lot of document analysis, you find yourself constantly having to figure out, you know, well, which one's right? And if you've ever been in that position, it's very frustrating because you don't know a priori usually. So that sometimes that can take a long time to untangle. So some of the benefits of LML. Well, first of all, I think it's broad. It's certainly trying to look at the problem across the entire life cycle. So it's meant for that full breadth of information. So that's why it includes the programmatic kinds of elements like risk, decisions, other things like that that are important for big time for schedule. So it's a lot of different things that you need for just capturing the other domains I mentioned. Being ontologically based is, I think, a power because this lets you translate between different languages pretty easily. And that's where we get the title of the thing, is from LML to SysML and back, is that ontological base enables that. And I mentioned earlier that all the capabilities of SysML, that all may be a little strong. So I will hold out that there may be some things we didn't capture enough in 1.1. And of course, we're always looking for feedback on that in the language. Of course, the simple structure, I think, is very important. Keep it simple, keep the language simple, keep the words simple, and try to keep them as unconfusing as possible to people in terms of having multiple interpretations of what something means. The group worked very hard on making that right. Also, it's useful to stakeholders across the life cycle. That's almost the same as broad, but that's such an important point. I want to make sure we emphasize that. So, very quickly, I'm going to go into a live demo to show you some of the aspects of it. Get to the right. One that's supposed to be up. There we go. So, Innoslate. So we're looking at Innoslate in diagrams view, and right now I'm showing you on top here the action diagram and an activity diagram, and as you can see just from the thumbnails, they look pretty similar. So let's take a look at one of them. Take a look at the activity diagram. So here's the full activity diagram, and action diagram. And you can see how it links together. They can be decomposed. So the decomposition, that decomposition has a loop and an OR construct in it. I should say special case of action called a loop and a special case that's an OR. And these have the properties of showing that the different obstacles are found or not found, or avoided. And of course the loop action specifies how much it is. Now notice that on the attributes on the side here, there's things like duration. You could add a start time, so if you want to use it for project planning, you can put specific times and dates for a schedule. So you can start capturing that kind of information that way as well. Obviously, I'm not using best practices because I've not put a description in for each one of these. So you need to go back and do that, actually. So anyway, and of course, you can go back up to the parent diagram and see it that way. Well, that's not the only way I want to visualize it. I'd really like to see it as an activity diagram because, gee, I've got to talk to people who do understand SysML and like it. So all I have to do is click Activity Diagram, and now it had already been created and adjusted, but that would have automatically created basically the same chart. I would probably have to move some of the boxes around and make it look prettier, but that's about it. So that information is there. You see the little fork symbol, it indicates decomposition. In the tool, you can click on it and get decomposition. And then you notice that the special cases of actions now become the symbols, the diamond symbols. But if you'll notice, they still are the loop action and the obstacle found as the OR action, and that's just an endpoint, so it doesn't really have any actual information in it. So these are the same things in the ontology. They're both actions, but they are now showing it as the activity diagram shows. In fact, in the tool, both can be simulated with Monte Carlo and discrete event simulation. Again, I can get back to the parent by doing that, and working through it. So now, if I said, gee, well, really, I like IDEF zeros. So let me go capture the IDEF zero for this. So again, it tracks the IDEF zero. It shows the different mechanisms. I was just scrolling down to show you the mechanisms. So it shows you that these have been allocated, and they're working down the input-output trail. So, and that one, of course, we don't have very much in the way of input-outputs, but you see, I just clicked it, and there it was. Let me go back up to parent for a second. Let's take another look at this. We have other ones, a classic n-square diagram. So you can see the kind of things with an n-square diagram. Again, all these are live, and you can manipulate things right here in this diagram as well. So every diagram that we have in the tool is live, and you can work with it. And if you make a change in one place, it will automatically make the changes everywhere else. That's the beauty of using the ontological base, is that now I have one instance of an object, but many different ways to show it. The other diagrams that we have available, you can see the different ones. Now, by the way, these were not here before. This IDEF 0 and the n-square chart were not in that list before. You may not have seen that, but they weren't there. It just got added by the diagrams view. So if you want to just work in LML, there's an LML tab. Or if you say I really want to just work in SysML, I can have just the SysML set and work through that. And here, in this diagrams view, you can create new diagrams, any kind of new diagram you want. If I want to create a new SysML diagram, maybe a block definition diagram, that's all I'd have to do is click that and make that work, go that way. Yeah, that's the other side of this, is the physical side. If I select the block definition diagram, so here's the robot decomposition. You can see the different ports, things like that, the block symbols. All these things, again, are editable. You can work with them and create what you want with them, the different values. Those are actually characteristics. You notice when I click on something, it will show you the class over on the left-hand side at the top. So the whole thing's an asset. If I come back off that and click one of these characteristics, so density, and it can have a value in units associated with it. So if I wanted to see the physical equivalent in LML, I would just click the asset diagram. And again, I hadn't created this before, so what it did was create the same information, showing you the different aspects of it. Now, the ports are actually, if you think about a port, it's really a sub element. It's a decomposition of the main one. So that's why we're showing it this way, as these are kind of external or internal things that are showing up on the diagram. Diagrams view. So this will let you work however you really want to work, going back and forth as you need to. Scrolling back down through some of these. And of course, one of my favorites is the spider. This shows you the traceability of all these different objects. And the spider diagram is probably the most powerful diagram once you understand the ontology, because you can add existing, so you can add things to this diagram, you can add new ones, you can create new relationships. If I got a new action, all I have to do to create a new relationship is this, and it'll say, well, what action, there are no, we don't have anything between a conduit and an action, so there is nothing in terms of relationship. If you decided you wanted something, you could extend the schema and add that relationship, and then it would show up here too. If you don't like anything you did, you can always discard changes, and it brings you back into the original view you were in, if diagrams view or database view or any other views. So that's pretty much a quick thumbnail. I wanted to give a little time for questions. And Elizabeth, I'm going to turn it back over to you for questions.
Thanks, Dr. Dam. We've received several questions already. If you haven't done so, please send your questions through the panel on the right. Dr. Dam will answer as many questions as he can before our time is up. All right, for our first question, we have, for a spacecraft systems model, once requirements have been identified down to at least the subsystem level, what is the best way to add verification statements to the model and characterize them as analysis, inspection, test, and/or demonstration? Do you use labels to characterize them?
So the answer to the last part is yes, we use labels to characterize the difference between them. Many of those are already available in the database. Now this particular diagram, this particular database doesn't have any requirements in it, so let me add one and call it test requirement 1 and so if we wanted to say that's a verification requirement, there's a label for that, and so that keeps my verification requirement. Then I can go through and trace it back to whatever is the that I want to have it work to. So let's make that the robot, and then add it, and that does that traceability, and I can see it very quickly by looking at the spider diagram. What I just created was this test requirement 1, tying it back to the robot. And again, if I'm not sure what this is, you can see the different attributes, but you can also see the labels. You click the metadata tab, so the test requirement has that label of verification requirement. So I think that hits all the different things that were in that question. Please ask another one if that didn't.
Our next question is, once items have been identified for analysis, inspection, test, and/or demonstration verification, do we then create corresponding actions and artifacts that form the basis for test plans, reliability analyses, strategy papers, hazard lists, etc.?
Yes, and in fact, one of the things we offer in the tool is something we call documents view. And so we have test plans as one of the templates that's already in it. And so I could my test, give a number, description. I can start with blank document, or I can use some test plans with guidelines that are available. And we're always looking, by the way, to add to that set. So if anybody has a really good standard, we're happy to add those in. And so here's some of the things that we've already generated, and so you can go ahead and edit these and work with them. The nice part is they're not just text, and of course you can underline, bold, italics, add pictures, tables, hyperlinks. So you can add all kinds of information into each of these paragraphs. And when you want to, though, you want to look at it as an entity, I can then look at that and see how it ties back to other things. I can again trace it back to something. And let me see, what did I just, so maybe I want to look for characteristics. Just want to see what characteristics I have available. So let's say this has something to do with density. It doesn't, but and then that would give me that traceability back. So again, I can take all my model and link it together with my test plan. So now, as I'm trying to understand how things are connected to each other, they'll stay connected. And again, of course, very important to look at that with a spider diagram to see how we just connected density to this purpose of the test plan. I hope that helps answer that question.
We're getting a lot of questions about today's recording. We are recording this, and I will upload it to YouTube right after we're done, and I will send an email out to everyone. Thank you so much. Our next question is, will the discrete event simulator be expanded with more capabilities in the future?
Oh, yes. In fact, in the very near future, we're actually in alpha testing of new discrete and Monte Carlo simulator capabilities. One of the things we were doing is migrating the simulator from the back end, where it was on the server end, to the client end. And what that allows us to do is have more interactivity quicker with it, and it uses then your processors. So you have, most machines today have at least 2 cores, if not 4, and then we can use those powerful data engines that are right there in your desktop that can actually conduct the simulation itself.
Our next question is, are there ways to quickly count aspects of the model, i.e. requirements, actions, etc.?
Oh, sure. So one of the things is there's a dashboard, and the dashboard has the statistics panel on it, and you hover over it, see the different types of statistics of it. And so you notice I didn't have a lot of requirements. Here's the one requirement down here in the corner. And then you can see with labels, it was a verification requirement. So again, that's very quick. I have a total of 192 entities. It also, notice, it tracks who changed what when, and there's also a model maturity checker, which has different types of heuristics, which we got from Stevens Institute of Technology, which shows us how well we did with things, and so we can see what failed and what, and that helps us understand better what do we need to fix. And so there's a lot of information to capture those kind of aspects that you're looking for.
Our next question is, can you add other entities to a document in document view, others than statement and requirements?
So in documents view, no, it's just statements and requirements, because that's what you're doing, is creating a document. But you can certainly link it to the other entities, and one of the things I like to do is create multiple tabs. And so since it's all browser-based, you can create multiple tabs, put them in separate windows, and work together with them more quickly and easily. So it actually gives you that whole breadth of being able to work with it.
Our next question is it possible to select the relationship direction on the diagram with corresponding change in verb/object?
Again, that's the kind of thing you'd have to do through the schema extender. Relationships, though, in the tool are designed to be two-way, so you have flow between them. But if there's a particular directionality that you want to use, we use that verb. So decompose is decomposed by. So you can see how that would be. Obviously, the decomposes are children decomposing the parent, and decomposed by. So maybe I have it the other way around. Yeah, decomposed by. So anyway, I think you'll find it's pretty easy to understand that ontology once you get into it.
Is there a direct mapping of LML to DODAF aspects for the ontology?
I'm sorry?
Is there a direct mapping of LML to DODAF aspects for the ontology?
Oh, yes. In fact, that's in the specification as well. And we did that to create the DODAF view, which is a dashboard as well in the tool. There's a DODAF dashboard now. It adds a lot of labels when you do it, but it creates that and sets it up for you. And it automatically does the DM2 statistics, so you see those entities as DM2 entities. So if you're used to the DODAF meta model, and of course one of the things we do for the AV2 is download the physical exchange specifications. So you can really get into that whole DM2 ontology if you want and see that mapping.
I would like to read some comments from Warren Vaneman. He is, for those people that don't know, Warren Vaneman is a professor of practice in the Department of Systems Engineering at the Naval Postgraduate School. He is also the chairman of the LML committee. He said, I believe that LML can serve as an ontology for SysML. Threedenthal and Burkhardt identified 8 MBSE effectiveness measures: expressiveness, precise, presentation communication, model construction, interoperable, manageable, usable, adaptable/customizable, which can be used to assess modeling language and tools. Using LML as the ontology for SysML should be able to help SysML's expressiveness, precision, presentation communication, and help it be more interoperable if implemented similar ways by different tool vendors.
Well, thanks, Warren. You said more than I could have done it. So, yeah, you also, I mentioned, I saw a comment about that that LML could form the ontology for SysML if they wanted to adopt it. I think we'd be thrilled if that was the case.
That's all the questions and comments that we have so far. If you have any others, please feel free to send them to us. We would love to answer them for you. We'd also encourage you to visit our website and our blog, as well as connect with us on social media. That concludes today's presentation. Thank you again for your attendance, and we hope to see you again at our next webinar in March. Please enjoy the rest of your day.